So that was a quick demo of the different assert statements as well as unit testing in IntelliJ. And now we are going to talk about something called debuggers, which are basically tools that are integrated into your IntelliJ or any different IDEs that you might be using that help you with kind of like debugging your source code or finding errors into your program. These tools are especially beneficial when you are dealing with millions or hundreds of thousands of lines of source code, because it becomes practically impossible to track a bug by using assert statements or using print statements. So these tools help you to actually trace or track the source of that error. Within the context of web languages, if some of you might have used HTML, CSS, if you use your browser and go to a particular website, and if you right click and go to inspect element, those are basically the set of debugger tools that are provided within the browser. But in case of IntelliJ, we use a debugger button. We are going to do a demo very soon. But in this slide, if you see this bug button, if you actually run this, this means that we have started the debugging mode in IntelliJ. So debuggers basically constitute of some components, which is breakpoints, and breakpoints are basically entry points of your debugging process, which is if we do the run process, the entry point is something called void main. But for debuggers, you need to have breakpoints, which are denoted by these red dots. And if you click this particular area in IntelliJ, you can add these dots and remove these dots. And you can add as many as possible. And they allow you to basically start the process at the line next to the dot where you place it, which is if you place the dot here and you try to run your program, you will see the actual constituents of that line once you click the next statement. We are going to do a demo very soon. The second constituent that we use is called step through, which is one of the functionality that's provided is step through, which is we have like different step in, step over, step out, and we are going to discuss this in the next slide when we are going to do a demo. There's the third constituent, which is called stack trace, which keeps a track of the functions or the frames, which basically allow you to see how the data is being passed from one function to another. And the last one is the variable watch, which keeps a track, which is a window that keeps track of the variable values within each stack frame. So let's say if you click let's say if this program had two different functions like int sum and void main, and if you were in your int sum, there would be another stack frame, and that stack frame might have different variable values compared to the other variable values. They are pretty similar to the global as well as the local values that we were seeing when we were drawing those pictures in our usual lectures, like how every function has its own local memory, and that memory is actually destroyed, or that entire stack frame is destroyed once the function has been executed. So in most cases, you must run in debug configuration to enable these, which we are going to discuss. We are going to do a demo in the next slide about how to use debuggers and what are the different functions that are supported by the IntelliJ debugger. So this video is about the debugger that is supported by IntelliJ and what are the different functionalities that this debugger supports. We are using the same program about like count runs, as well as we have two different arrays. In the first array we have 4 zeros, in the next array we have 16 zeros. The fourth 0 arrays, we are changing the value at index 0 to 1. So that means this array will now look like 1 0 0 and 0, because initially it was looking like 0 0 0 and 0, and now it looks like 1 0 0 0. Next, we are basically executing the count runs function on the data 40 value. So how you start the debug mode is by using this debug symbol, which might be on the second nav bar from the top, right next to your run button. And if you click on it, you basically start the debug mode. I'm going to just maximize this. And if you see, it has two different components, the console, which actually prints the output, and the debugger, which shows you the different frames as well as the variables, which is the different stack frames it has, as well as the different variables. Right now, you see that there are no frames available and variables. Why? Because we did not define an entry point to the debugger. And how we define the entry point is by using something called breakpoints. So let's say we define an entry point right here, and there might be another entry point right here. Let's do a little bit more, which is what these entry points mean is if you use, like, let's run this program again and you'll see what I mean by entry points. So your code for debugger actually starts at the first entry point, and if you use this run or resume program, this actually jumps from one entry point to another, which is if you have multiple of these breakpoints, and if you use this run button, it actually jumps from one breakpoint to another. That's the number one function of this particular operation. Let's start this once again. Now we see there is another function which is called step over. This actually does not jump from one breakpoint to another, but instead jumps from one statement to another. So even if we didn't had, like in this case, now we can see it's jumping from one statement to another. Okay. And then there's one more called step into. Like if we jumped from this statement to the next one, nothing happens. But if we use the step into, it actually goes into that specific function, which is in this case count runs. It will go into that specific count runs and execute the line by line into that function. So let's start once again the debugging process. And if I use now step into, which is this one, so this now actually goes to that individual function, which is in this case it actually went to the println function, but if you just do something like count runs here, because println is also a function, so it actually went into the print stream function, which is the trace of like what actually the println does. You don't need to go into that, but let's say if you're just to have a particular count runs here, and I'm trying to execute it once again in the form of debug mode. Let's do that once again. And now if I click on the step into, this goes into the count runs function and basically executes each of the statement one by one. Okay. Now let's start this process once again and see which of the functions are most useful and how you can use them. So I'm going to minimize this count runs function. I'm going to remove the breakpoints because we are basically checking what is the value of this count runs. I'm going to go back and paste it in my system.out.println. And now I'm going to start the debugging process from the entry point, which is I've defined a breakpoint at line 25. And now I'm going to start the debugging process. So you'll see the first thing you notice is it has just one stack frame in this debugging process because we are in this main function. But if we actually follow the step into, you'll see like once we go into another function like count runs, this will actually have multiple frames to go into that function. Like now we are in the println function, which is a part of the import java.io library. We are not going to go into that, but it gives you an idea that we are in a different stack frame and it has different values of this particular variable. So I'm going to start the debugging process once again. And now I'm going to use just the step over and we are going to see what these values actually mean. So when we start this, the entry point, which is the breakpoint, we see that the values of a particular variable have not been executed. These will be executed after we are at a line after the breakpoint, which is like, let's say we do a step over now. So now you can see the data 4 zeros contains 4 zeros, which is visualized by this red line, and a light scale gray version containing 4 different zeros. Now we have another variable. Again, if I step over it, you see that this data 16 zeros has 16 zeros. It says +6 more. And now once I change this, initially you can see data 4 zeros is 0000, but after the execution it will be like 1000. And once I finish this execution, you'll see the value of the count 0, which gets actually printed to the console, which is the value is 2. So this is one way to use the different functions. If you want to access the different the actual value of these functions, which is if you want to visualize this count runs, you can actually go into that by using the step into function, which is, I'm doing it again. Now I'm using the step into function, and in this case the count runs will actually go into the function and show you the values one by one. So in this case you can see we have a new function in the stack, which is count runs. Now we have just one variable, which is the flat data that has been passed. It's pretty similar to the ones we draw in the draw on the board in our class, if everybody remember, which is we had on the left, which was a stack memory, there was on the right heap memory, and whenever we are accessing different functions, they basically create a memory for the local variables, which is, in this case it is flat data, and you can see the flat data's values as 1000. And now if I continue my process of step into, or if you want, since I'm already stepped into the function, you can use just the step over in this case. You can actually execute a statement each of the time and actually visualize these variables, how they are looking like in the for loop. One last thing that I'm going to cover in the debugger that's also useful is you can use this last function, which is run to cursor. So in this case, you can just place your cursor on a particular line. If you click run to cursor, this actually goes into that particular cursor frame, which is like my cursor is right now here, and it basically acts like a breakpoint. So your cursor goes right here and it executes the line right before that. So this actually acts just like a breakpoint. Again, you are seeing the variables in your main, which is you have the arguments, you have data 4 zeros, data 16 zeros in this particular variable. So the debugger is very helpful when you're trying to find errors in your program, and is a very helpful tool that can be combined with assert statements to find and fix bugs. That's all for this particular debugging tool, and now we are going to discuss more about exceptions in the next slide.